In this chapter, a new data structure is going to be defined, which is known as a data frame. So far, we have seen the following four data structures. First of all, a vector, and that is a linear arrangement of data values. Second thing we've seen is a matrix, which is a rectangular arrangement of data values. An array can be viewed as a higher dimension matrix. In other words, it can have 3, 4, 5, 6 dimensions. And in the previous chapter, we introduced something known as a list, which is a non-atomic data structure, which means that you can have different data types in a list. The data structure that's going to be introduced in this chapter is known as a data frame. And data frames are very similar to matrices in that they have rows and they have columns. A data frame will carry the best features of a matrix and a list. The good features of a matrix that it carries is you can get to the elements by specifying a row or a column. The best elements of a list that it carries is that you can have different data types within a data frame. A lot of data comes in this way. If you look at, say, medical data, you might have in one column say, gender, and gender might be coded as a logical, true, false, because it's a 0 or a 1. You might then also have another, which is perhaps a numeric, such as cholesterol level. Then you might have another which is a character string, and that might be the person's name, and on it goes. So not all data comes in one form. Sometimes it's mixed like that, and the data frame is one of the best data structures for capturing that. The way the designers of R have set things up, columns within data frames can have different modes. Once you're in a column, it's atomic. You've got to have the same mode within a column. But going from column to column, you can have different modes or different data types in there, and that'll be illustrated soon. The columns are often labeled with a header. This is another example of metadata, just like the names that we saw earlier, and that will be illustrated soon. Rows tend to be observational units. This is just in practice, such as people, cars, etc. Those are observational units. And columns tend to be measurements that are collected on observational units. So row 1 might correspond to data collected on person 1. Row 2, data collected on person 2. Or, if you're looking in the case of cars, row 1 might be data from car 1, row 2 might be data from car 2, etc. The syntax that is used for creating a data frame is data.frame. That's how they're created. And then you put in column 1, column 2, etc. And if you want to put row names or column names in, that can be done down the line. Let's start with a simple example here. What I'm going to do is start out with the definition of a vector. I'm going to call it bool, which will be for Boolean. What I'm going to do is I'm going to set it to true, false, true, false, true. You can see that I have abbreviated those here, but T and F have not yet been defined. You can see that by the uppercase. So abbreviating them as true and false in this case is safe. You would not want to do this if you were writing an R program. Next thing I'm going to do is set a numerical vector. I'm going to let this be the vector 4 through 8. Notice that this has 5 elements in it, and there they are in the upper right, 4, 5, 6, 7, 8. Next thing I'm going to set up is a complex, and I'll call that comp. This is a vector of complex numbers, and I can do that by using the complex function. I want this to have 5 elements. I'll let the real parts go from 2 through 6, and I'll let the complex parts go, or the imaginary parts go from 6 to 2. finally, to put in a character vector, let's call it char, I'm going to use the uppercase letters that run from 18 to 22. So these four vectors that I've defined, and you can see them up here, they all have length 5, and I'm going to combine them into a data frame. And so I will name the data frame D. You can give it any name you'd like as long as it's not a reserved word or such. And this will go into data.frame, and that is using this syntax right here. And now I'm going to define my columns, and I'll just put my columns in exactly the same order as I had them before. I will put in Boolean first, and then the numerical, and then the complex, and finally the characters. And now D is in there, and now you can see in the upper right, D has been defined, and it has 5 observations of 4 variables. So if I go ahead and type D at this point, I'll see what that data frame looks like. What you can see is the columns here are the Booleans, the numerical values, the complex variables, and the character strings. And the labels have been inherited by the names of the vectors that I set, bool, num, comp, and char. And furthermore, R will go ahead and it will number each row consecutively in the data frame. This is like a matrix in the sense that I can go down here and I can type n row of D, and it'll say there are 5 rows in the data frame D. I can also ask how many columns are there, and there are 4 columns. A useful function is known as head. If this were not just 5 rows, but rather it was 500 rows, sometimes I don't want to type the entire name of the data structure because it'll fill up one screen after another after another. The head function will give you the first 5 or 10 rows just so you can see what it looks like, and there you see the first 5 come out. So this will do the whole data frame. It'll display the whole data frame in this case, but if you had a larger one it would just produce the first few. If you want to see the last few, there is another function that is useful called tail. So I could type in tail of D and I just get the last few lines. Here's another function which I like. str is short for structure, and this will give you the structure of the data frame. First thing it does is it tells you that this is indeed a data frame. It tells you there are 5 observations on 4 variables, which is exactly what we got up here in the upper right. But it gives you more than that. It also tells you that the first one is bool, named bool, and it is a bunch of logicals, and here are the first few of those. And the second column is num, and you can see 4 through 8. The third column is named comp. It is a vector of complexes, and there they are. And finally, char is going to be what is known as a factor with 5 levels. That's something we haven't covered yet, but if you want to look up factors, they are covered in the textbook. Now, next thing I'd like to do is take a summary. The summary function lets you summarize the particular data structure that is out there. In this case, it is the data frame, and you can see each column here is summarized. Here's bool. Its mode is logical. There are 2 falses and 3 trues in that vector. Second column is num. The minimum is 4. The maximum is 8. It'll tell you the first quartile, the third quartile, the median, and the mean. So you get a summary of that numerical. Here is the third column, which is named comp. You can see it has a length of 5, and there are complex variables in there. And finally, the last one is named char, And you can see there is one occurrence of R, one occurrence of S, one occurrence of T, etc. STR is a useful way of looking at just the structure. Summary is a nice way of summarizing a particular data frame. So let's start in and look at one of these. I'm going to go ahead and type D here, so that's in front of us. First thing I'm going to do is ask for D11. You subscript these exactly the same way that you would subscript a matrix. So this is going to give me the first row in the first column, and so that's going to return a true. If I leave one of these blank, it's exactly the same way a matrix handles it. This will give me the second row. It'll give me all columns. And in this case, it comes back in that fashion. I could go the other direction. I could say D blank, comma 2, and in this case, it will give me the second column rather than the second row. Another thing you can do is use the syntax that is taken from lists and say, what is the second component here? And it turns out that second component is going to be the second column of the matrix. Another thing you can do is you can say D, and this time what you can do is you can put in the name of the second column, which is num, and that's still another way of getting to that second column. Another thing that you can do is you can say $2, and that is also the $ extractor from lists, and this will give you the second column. For some reason, oh, it's not named 2. What's it named? It's named num. So in that fashion, you will also get the second column there. Now at this point, we're going to leave D behind and set up a second data frame. This one will be a little more practical than the first one, which contained things like complex numbers and strings. I'm going to sweep what we have away here, and I'm going to define something called charity. And charity will be a data frame. And the first column in the data frame will be called cash, and I'll put a 1 through 3 in there. Second would be contributions by check. Put a 2 through 4 in there. And the third column will be contributions by credit card, and that will be a 3 through 5. And then what I'd like to do is put in row names. So I will put in the following names. I will put in Huey, Dewey, and Louie. Hopefully I've gotten all that right. And there is now, you can see over here in the upper right, there is a data frame that has been set up named Charity. And if you type Charity at this point, you'll see that now we actually have not only the columns labeled as cash, check, and credit, but we also have the rows labeled by the names. There's Huey, Dewey, and Louie. And now what we can do is we can work with that particular data frame a little bit. So let's create another data frame called Charity 2. And Charity 2 will be a transform of Charity. And what we're going to do is set up a total, which is cash plus check plus credit. So in this particular case, we have something called Charity 2, and you can see a new column has been created, which is the sum of the other columns. You could also go in here and use the subset function, which can be used on a data frame. So for example, if I want a subset of charity 2, and let's say I want the subsets associated with credit being greater than 3, and you'll see the credit contributions are greater than 3 for Dewey and Louie, so we know those are the two that we're going to get out. And then it has a select argument, and let's say I only want to look at the cash and the total when I get that subset. So what it'll do is it will give me the lines for Dewey and for Louie, because those are the two that have credit contributions that are greater than 3. And what it will output is it will output just the cash and the total values, ignoring, of course, check and credit. So these are ways that you can work with data frames, and we'll be seeing those throughout the remaining chapters. So take a little bit of time and go into R and set yourself up a data frame and experiment with it a little bit.